The superposition theorem is most commonly used theorem in circuit theory and in problems of analog electronics and basic electronics. So let's understand what is superposition theorem and how do we use it. So as you can see in this picture, there are two sources. One is a current source, another is voltage source. So this is where the superposition theorem is used. Wherever there are multiple sources, and when we are interested to determine either current through a particular branch or voltage across a particular branch, because of all these sources, what do? We apply the superposition theorem. So how do we do it? We consider one source at a time, and and other sources are cut off, and then we do it for all the sources individually. We algebraically sum the contribution in a branch called as superposition theorem. Let's understand. So for understanding superposition theorem, linearity is a principle that is very important. The circuit must be linear. So an element that observes relationship, that is linear relationship between an input and output, or the output is proportional to the input. As we know that V is proportional to I, we write I is equal to I, V is equal to IR, and even the additive principle is valid. We can write V1 equal to I1 into R, V2 equal to I2 into R. So resistance is a linear element. Why? Because cause and effect, voltage and current is following the linearity. So this is additive principle. So when the additive principle is there, when linearity is there, when homogeneity is there, it's called as linearity, linear circuit. So the superposition theorem is valid in linear circuit only. When you see that, when we plot I versus V, it must be linear. When we have other equation, P is equal to I square into R, so this is non-linear, where you can see quadratic relationship. So it will not be linear relationship. Alright, so let's understand what is superposition theorem. Voltage across or current through any branch. Voltage across or current through any branch or element in a linear circuit is algebraic sum, because we consider the polarity, plus minus may be there. So we don't say normal sum, algebraic sum of voltage across or current through that particular element due to individual independent sources acting alone. So if there are multiple sources, for every individual source, we calculate voltage or current, and then we finally sum it algebraically. So to analyze the linear circuit with more than one independent sources, by calculating the contribution of each independent sources separately. Like you see here, this is one example where we have two sources, one current source of 8 ampere, independent source, it's not depending on other variable. There is other voltage source 20 volt, and suppose we are interested to determine the voltage across 2 ohm. So what we can do? We can consider first this current source or voltage source, and then second time other source. So when we calculate the voltage across 2 ohm due to 8 ampere, we'll consider the second source as cut off, off. So when we say off, means it has to be removed. So how do we do it? What are the steps? As you can look at the first one circuit diagram here, how many sources we have? 2. And when we are interested to determine, say, current through R3, so see here, we are calculating current due to E1, E2 is replaced by a short circuit. Similarly, in the second case, we are calculating the voltage by E2, current due to E2, and the first source is considered as the short circuit. Why do we do it? Because we turn off all independent sources except ones. So determine output voltage or current due to active source. See here, we are calculating due to E1, and in the second case, we calculate due to E2. And then I3 dash and I3 double dash can be added. One may be positive, one may be negative. So therefore, we have to consider the polarity as well. So cutting off means repeat for each of the other independent sources. Cut off means replacing by its property. We know that 0 volt means what? Short circuit. Cut off means let its value be 0 volt. 0 volt means short circuit, it's, and resistance is 0 also, internal resistance is 0 of ideal voltage source. We can also say the voltage source becomes ideal, or we remove the voltage source, so voltage becomes 0, therefore it becomes short circuit. So turn off all the independent sources means independent voltage sources are replaced by a 0 volt, and if we replace by current source, replace by 0 ampere means open circuit. So let there not be any current or voltage and therefore replaced by short and open circuit respectively. Dependent sources will remain there. We can't remove them intact because they are controlled by some other variables somewhere in the circuit. So let then there be there. You see here there is an independent source, so it will remain there even if we solve the problem. Turn off the voltage sources, that is independent sources, current and voltage sources, but as far as the dependent sources are concerned, dependent sources will remain there. Let's take one example. You see here, let's try to calculate voltage across 4 ohm, and you see there are two sources. So if you go to the second diagram, look at here, we are ignoring the current source, so 0 ampere. So you see the circuit becomes simple. V1 is the voltage across 4 due to the first source, 6 volt here. It's nothing but a voltage divider. 4 divided by 4 plus 8 into 6 will get V1. Second case, you see here 3 ampere is considered. The first voltage source becomes 0 volt. So it's very simple. 3 ampere is divided into two parts, 8 and 4. What current will be there in 4? 8 divided by 8 plus 4 into 3. Current divider, and then we can multiply this I3 by 4. We'll get V2, and then we can add V1 and V2. So you see here, this is being explained. How we'll calculate V2? V2 is the voltage across 4. That is 4 into I3. So what is I3 is also calculated. As I told you, 8 divided by 8 plus 4 into 3 ampere. So it's 2 ampere. And similarly, V1 is directly calculated. We can calculate by voltage divider circuit. 4 divided by 4 plus 8 into 6. 4 divided by 4 plus 8 into 6, that is 2 volt. So both the polarities are coming as same, 8 volt and 2 volt, and therefore the voltage across 4 ohm will be 10 volts. So this is the simplest example of the superposition. Now let's take one more example where there are dependent sources. Look at here, there is a dependent source 5IO. So what we can do, let's consider the first one 4 ampere, second has to be removed, short circuit. So we can assume some current, apply Mace or loop law, and then we can calculate, right? And similarly, in the second case, look at here, this becomes open circuit. This is present, again solve the current. So whatever we are interested in, and finally, suppose we are interested in, either current through 3, current through 4. So we'll calculate all these loop currents, and then we can, determine the current through 4 or 2, wherever we are interested. So dependent sources will remain there. Whenever independent sources are there, the same rule will apply. So this is very simple and effective law or the theorem called a superposition theorem, which is used to simplify the complex and bigger circuits, and to determine either the voltage across or current through a particular element in the circuit. Thank you so much. If you like this video on superposition theorem, please comment on the video, please like the video, and also spread with your peers and friends, and also please do not forget to subscribe the channel. Thank you so much.